This is one of the more amazing problems, I think. We have, and this is true, I actually looked this stuff up. So some drivers have actually survived forces of 160 Gs, which is a force for NASCAR, which is a force of 101,920 newtons. Like, just picture that for a moment. And if the car was originally going, so we're going to say initial velocity of 38.8 meters per second. The question is, how long is it going to take them to come to a stop? Okay. And they gave us the mass, which is 65 kilograms. One thing they didn't exactly give us, but that we can imply, is they're coming to a stop during this collision. I mean, unless this is a hit and run or a side swipe or something like that, they're going to be coming to a stop and in a crash. That's what we would expect. So how can we do this? Well, there's only one equation that kind of ties all this stuff together. You are going to have to use the idea that impulse is equal to the change in momentum. Let's spread that out. Impulse is force times time, and the change in momentum is P final minus P initial. If you struggle with this idea, you might want to just put that on your note card. So let's see what we currently know. We know the force, and we're looking for the time. So we're pretty much going to have to go find these momentums. So let's go figure out how we could do that. Well, P final, like we said, the final velocity is going to be 0. So the final momentum is going to be 0. How do we find that initial momentum? Well, we're going to use mass times velocity. So our initial momentum is going to be 65, and our velocity originally was 38.8. When we put that together, we get 2522 kilograms times seconds. Kilograms times, why do I screw that? Kilograms times meters per second. Okay, so now we know the initial momentum. We could put everything in. So force was 101,920 times time is equal to our final momentum is 0 minus 2522. Okay, so how do we do this? So we have 101,920 times time is equal to negative 2522. One thing I should have realized, that the force acting on the guy is actually going to be negative because it's going to slow him down. If you forgot that on the test, you would still actually get the same answer for time. It would be negative time, and you'd be like, oh, I forgot it. So time is going to be equal to 2522 divided by 101,920. This could be really short a period of time. Seems unrealistically short, but this is what the stuff was on NASCAR. So yeah, really short. So 0.02 seconds. That is a huge change. If they're driving forward, and again, I don't know, they didn't have a ton of information about where they got these facts on there. If they're driving forward and they come to a stop, there's other ways to experience these G's through rotational motion, but I'm not going to get into that here.